So in this segment, we're going to look at the evidence that we have two systems of thinking, starting with evidence that we have two systems of categorizing. And then in the next segment, we'll probably look at reasoning. So first, I'll give some really simple intuitive evidence that we have two systems of categorizing. This isn't experimental, it's just kind of linguistic. So look at these two sentences. Technically, a manatee is a mammal. Technically, a tomato is a fruit. Now, those are perfectly natural sentences. If I say to you, technically, a manatee is a mammal, you don't say, why the heck did you say technically? That's a really weird thing to say. Or if I say, technically, a tomato is a fruit, you just kind of nod and say, yeah. You don't say, why did you say technically? That's so weird. But if I said, technically, a horse is a mammal, or technically, a banana is a fruit, you'd say, it's really weird that you said technically. Why would you say technically a banana is a fruit? It's just a fruit. Why would you say technically a horse is a mammal? It's just a mammal. And that sort of contrast, where it makes sense to say technically a manatee is a mammal, but it doesn't make sense to say technically a horse is a mammal, suggests that we have some temptation to say that a manatee isn't a mammal. We have some temptation to say that it's something else. So that's some intuitive evidence that we have a system of categorization that wants us to say a manatee is a fish. Now let's look at experimental evidence that we have two systems of categorization. And we'll start with evidence of similarity-based categorization, that is, evidence that we have a sort of system one that categorizes things based on superficial similarity. And then we'll look at evidence that we have a system two that can ignore superficial similarity and focus on rules. So here's a really straightforward example. You have a series of images here. And what I want you to do, if you haven't done the exercise already, is pause the video and go out and find, I believe it's exercise 2. Well, actually, sorry, I don't think it is exercise 2. You can just do this on a piece of paper. I want you to rank these animals in terms of how much they belong to the category bird, in terms of the extent to which they belong in the category bird. So go ahead and pause the video and rank the animals from top to bottom by how much they belong in the category bird. So I'm just going to continue now, assuming that you paused the video and performed that task. Well, how do people typically respond? People typically say that the robin is number 1 or number 2, the blue jay is number 1 or number 2, sometimes they're tied for first. Then you get the bat as number 3, the flying squirrel is number 4, or you sometimes get the penguin as number 3 and the bat is number 4 and the flying squirrel is number 5, but something like that. Those three animals fall in that kind of range. And then you get the dog dead last. Now, why is this evidence of similarity-based categorization? Well, in this example, we judge some animals as more central to the category bird than others. That is, we'll say that a robin and a blue jay are more central to the category bird than a penguin is. And we'll also say that things that aren't even birds, like the bat and the flying squirrel, are sort of more bird than, say, a dog. Well, if we apply any ordinary concept by using rules alone, as opposed to using similarity metrics, that is, if we apply any ordinary concept in just the system 2 way, and we completely ignore the superficial similarity that drives system 1, then we're going to apply natural kind concepts, concepts of things like bird and tree and duck and kinds that you just find in nature independently of how we think about the world. If we apply any ordinary concepts by using rules, we're going to apply those kinds of concepts by using rules. Well, if we apply the concept bird by using rules, then we're not going to judge some animals as more central to the category bird than others. Any given animal will either be in the category or out. Bird, robin, blue jay, and penguin will be in, all equally in. We'd rank them all number 1. And the flying squirrel, the bat, and the dog would all be out. We wouldn't rank order those either. We'd say they're all out. So it would be a categorical concept. We'd say you're under the extension of the concept, you are a bird, or you're not under the extension of the concept, you're not a bird. We wouldn't say there's a degree to which you belong in the category. So again, we judge some animals as more central to the category bird than others. If we apply any ordinary concept through rules alone, ignoring the superficial similarity that drives system 1, then we do so for concepts like bird. if we apply bird by using rules, then we don't judge some animals as more central to the category bird than others. But since we do, it follows that we don't apply ordinary concepts, at least most ordinary concepts, by using rules. Rather, we apply them in part by using similarity metrics. And that's exactly what System 1 would have us do. When you say that a squirrel is more a bird than a dog is, your System 1's appeal to superficial similarity is what's driving you. Now let's look at evidence of rule-based categorization. Well, suppose I ask you this bald question. Which of these two is most similar? If you're going just based on superficial similarity, you're going to say that the stuffed monkey and the regular monkey are more similar. And you could even imagine that the stuffed monkey were much more like the regular monkey, that it looked just like the regular monkey. I just labeled it as stuffed. But of course, you're able to, in response to the question which of these two is most similar, say, well, the real monkey and the horse are most similar. They share something deep and important that the stuffed monkey lacks. And this raises the question, when I say which two are most similar, similar in what respect? In respect to shape, size, in respect to something deep and important like being biological versus not being biological. And the crucial point here is that when we do categorization, we sometimes categorize on the basis of similarity dimensions that have nothing to do with the superficial, that run deep, that appeal to things like the biological nature of the thing. And these respects seem to be rule-based, and recognizing similarity using these respects seems, in some sense, to require applying rules. Or at least, we often do it by applying rules. So that suggests we have a way of categorizing that fits with System 2. Okay. So there what we saw is evidence that we have a system by which we can do automatic superficial-based categorization, and that's System 1. And we have a system by which we can do deliberate rule-driven categorization, and that's System 2. And we're going to stop there, and in the next segment we'll talk about evidence that we have two systems for reason.